Now, in item number 3, determine whether the 3 tuple 581 is a solution of a linear system. So, we have a linear system here. This is 3. Then we have a 3 tuple which is 5, 8, and 1. So, just substitute the 3 tuple to x, y, and z. So, first we need to find this. Substitute the x. So, we have 5, substitute the y. We have 2 times 8, then substitute the 1, z. So we have minus 2 times 1. So then find the answer of this. So we have 19. The next is the second equation. Let's find what is the answer. So 3x minus y plus z equals 1. So substitute all the 3 tuple. Then we get the answer of 8. Then next, the third equation, which is this negative x plus 5y minus 5z equals 5. So again, substitute the 3 tuple. This is 5 plus 5 times 8 minus 5 times 1 equals 5. So we come up with the answer of 30. Since 19 is not equal to 3, 8 is not equal to 1, and 30 is not equal to 5. Therefore, 8, 5, and 1 is not a solution of a linear system. Now in item number 4, we have a question of the linear system below has infinitely many solutions. Use parametric equations to describe its solution set. So we have equations here. So we just need to choose one. So I choose this equation. So first, I need to transpose the 2x sub 2 to the other. So we have 6x sub 1 equals negative 8 minus 2x sub 2. Then divide it by 6. So we can get the x sub 1. So we have the x sub 1 of equals negative 4 over 3 minus 1/3 x sub 2. And now our x sub 2 is a parameter, so we can use a value of t. Then our x sub 1 will be equal to negative 4 over 3 minus 1 over 3t. Then our x sub 2 is equals to t. And now in number 5, given the matrices of A and B, find the indicated row or column. So we have a matrix here of A and B. So in A, the first column of AB. So the first column of AB, so copy the A and B, then multiply the two matrices. So we can get this answer. Multiply the two matrix. So we have the row into column. So 3 times 6 was 18. 2 times 0 equals 0. Then 7 times 7 equals 49, and so on and so forth, until we come up with this result, which is 67, 41, 41, 64, 21, 59, 63, 67, and 57. So we find the first column. So the first column of the AB is 67, 64, and 63 here. And now in B, find the third column of B multiplied by B. So we have a matrix here of B. So multiply by itself here. So first, 6 times 6 equals 36. Then 2 times 0 equals 0. 4 times 7 equals 28. The next is 6 times negative 2 is 12. Negative 12. And 6 times negative 2 times 1 equals negative 2. And 4 times 7 equals 28. Then and so on and so forth until we come up with this answer. So the answer is 64, 14, 38, 21, 22, 18, 77, 28, and 74. And now we can find the third column of the BB. So the third column is here. So the answer is 38, 18, and 74. Now let's find the second row of BB in C. So first we have a row of a matrix of B multiplied by itself B. So find the answer of the BB. So first multiply the elements of row into column again until we come up with the result of 64, 14, 38, 21, 22, 18, 77, 28, and 74. And now we can easily find the second row of BB, which is this. the 21, 22, and 18. This is the row of BB, the second row of BB. Now, let's find the first column of AA. So, first we need the matrix of A, which is this, then copy the matrix of A, then multiply by itself, so we can get the answer of AA. So, to get the answer of AA, we need to multiply the row into column, row into column, the elements of row into the elements of column. Again, here, until we get the answer of this. Negative 3, 12, 76, 48, 29, 98, 24, 56, and 7. So, now we can find the first column of AA, which is this. So, it is negative 3, 48, and 24. This is the first column of AA. Now, in number 6, verify that the equations below are valid for the matrices A, B, and C. So, we have a matrices here of A, B, and C. So, first in A, find the inverse of inverse A equals A. So, first we need to find A. So, determinant of A equals to the matrix of A, which is 2 minus 3, 4, and 4. So, equals to the A times D minus the B times C, which is the A is 2, the D is 4, minus the B, which is 3, then the C, which is 4. So we gather with the result of 20. So next we need to find the inverse of A. So we have here the 1 over 20 times the matrix A, but first we need to interchange the 2 and 4, then the sign of the given matrices here of the B and C. So we can come up with the matrix of 4, 3, 4, and 2. So now we can find the answer of 1 over 5, with 1/5, 3 over 20, and 1/10. So next we need to find the determinant of inverse A. So inverse of inverse A. So we need to do like this. So 1/5 times 1 over 10 minus 3 over 20 times negative 1/5. So we come up with the result of 1 over 20. Now we can find the inverse of inverse A. So equals to 1 over 20 times the 110 minus 3 over 20, 1/5, and 1/5, which is 2 minus 3, 4, and 4. Therefore, the inverse of inverse A equals A is true. And now in B, we have here the transpose of ABC equals the transpose of C times the transpose of B times the transpose of A. First, we need to get this. So we need to multiply first the AB, which is the matrix of A is here, 2, negative 3, 4, and 4, multiplied by the matrix of B, which is 3, 1, 5, 2. To get this result, we need to multiply each element of row into column. So we get the result of negative 9, negative 4, 32, and 12. Next is we can finally find the transpose of A, B, and C. So we need to multiply the A, B, and C. So copy the answer of the result of the A, B, which is negative 9, negative 4, 32, and 12. Then copy the matrix of C, which is 2, 0, 0, 3. Then multiply the two matrix column into row to get the answer of negative 18, negative 12, 64, and 36. Now we transpose it, so we can get negative 18, 64, negative 12, and 36. And now let's find the next equation, which is the transpose of C, transpose B, and transpose A. So we need to transpose the C first, which is this. We come up with this. Then the transpose of B, 3, 5, and 1, 2. Transpose of A, which is 2, 4, and 3, 4. Then multiply the three elements. So we can get the answer of negative 18, 64, negative 12, and 36. since the two equations have the same answer or result, then therefore A, the transpose of A, B, C equals transpose C times transpose B times transpose A is true. And now, number 7, find the inverse of the matrix below, which is this, negative 3, 1, and 2, 2. So, to find the inverse of this, we need to divide the 1 into 2 times 3, which is this, negative 3 and 2, A, D, minus the B and C, which is 1 times 2. Then, multiplied by the 2, negative 1, negative 2, and 3. To get this, we need to interchange this A and D. Then to get this negative 1 and 2, we need to multiply the B and C with negative. So we can get the negative 1 and negative 2. So to get the inverse, 2 times negative 3 minus 1 times 2 is negative 8. So we have 1 over 8 times the 2 minus 1 and negative 2 and negative 3. Then the result of the inverse A is equals to 1/4, 1/8, negative 1/4, and 3/8. So the inverse of this matrix is this. Number 8, solve the linear system using Gaussian elimination. So we have here our linear system. Then first we need to get our augmented matrix, which is here. To get this, we just copy the number of our linear system here. 2, 2, 2, 0, 2, 2, 0, 2, 5, 2, 1. So, since we are using Gaussian elimination, so we need to make our diagonal here to become 1 and have a side of 0 here. So first, we need to find our row 1 to become 1 here. So we multiply it by 1/2. 1/2 times 2 equals 1, 1/2 times 2 equals 1, 1/2 times 2 equals 1, 1/2 times 0 equals 0. So copy other row here. Next is we need to make our row 2 to become 0 here. So we need to multiply our row 2 by 4, then add by row 3. 4 times negative 8 plus 8, which is 0. 4 times 5, which is 20, plus 1 equals 1. 4 times 2, 8 plus 4, which is 12. 4 times 1 was 4, plus negative 1, which is 3. Then copy the other row here. Next is we need to make our row 3 to become 0 here. So we need to multiply our row 1 to negative 8, then add by row 3. So negative 8 times 1, which is negative 8 plus 8 equals to 0. Negative 8 times 1, which is negative 8, plus 1, which is negative 7. Negative 8 times 1, which is negative 8 plus 4, which is negative 4. Negative 8 times 0 equals 0 plus negative 1, so negative 1. So copy again the other row. Next, we need to make our row 2 to become 1 here. So we need to multiply our row 2 by 1 over 21. So 1 over 21 times 0 equals 0. 1 over 21 times 21 equals 1. 1 over 21 times 12 equals 1 equals 4 over 7. 121 times 3 equals 1 over 7. So copy again the other row. Next is we need to find our row 3 to become 0 here. So we need to multiply our row 2 by 7, then add by row 3. So 7 times 0 equals 0, plus 3, 0, so 0. Next is 7 times 1, which is 7, plus negative 7, which is 0. So next is 7 times 4 over 7, plus 3, negative 4, so 0. Then next is 7 times 1 over 7 plus negative 1, which is 0. So we already have our new linear system here, since we gather all the 0 in the side. So we have our new linear system here. So x sub 1 plus x sub 2 plus x sub 3 equals 0. X sub 2 plus 4 over 7. X sub 3 plus 1 over 7. Then we have 0 equals 0, which is, this is a mini solution because 0 equals 0. So next we need to find our x sub 3. Since our x sub 3 is a parameter, so we need to make our x sub 3 equals t. Then next we need to find our x sub 2. So we need to use this equation. X sub 2 plus 4 over 7 x sub 3 equals 1 over 7. So first we need to transpose this into this to become x sub 2 equals 1 over 7 minus 4 over 7 x sub 3. So we need to transpose our x sub 3 to become t. So here, this is the final answer of x sub 2. So next is we need to find our x sub 1. So here we use this. So we need to substitute our x sub 2 and x sub 3 here. So we have x sub 1 plus 1 over 7 minus 4 over 7t plus t equals 0. So transpose again. So we have x sub 1 equals negative 1 over 7 plus 4 over 7t minus t. So we have a final answer of our x sub 1, which is negative 1 over 7 minus 3 over 7t.